ion flux? And to get, you depolarized to plus 30, remember? And then it repolarized back down to rest. Do you need ion flux to repolarize? Yeah. And it could be as simple as this. Sodium comes in to depolarize, pump sodium out to repolarize, right? Let sodium come in, depolarize, push sodium back out, repolarize. Active transport takes longer than diffusion. Okay? Active transport takes longer than diffusion. So this is what we were looking at here. You should get incredibly familiar with this kind of graph that I'm drawing right here, because this is really what it's all about. Okay. Let's see what I did here. Minus 70 at rest. Graded potential, graded potential, graded potential, threshold. Action potential spike. Right? Somebody just like the Lakers. Oh, they won. It only takes 1 point. Depolarizing, repolarizing, hyperpolarizing, or what? Depolarizing. So depolarizing, threshold, depolarizing action. Now we said we come back down here like this.
Repolarizing and hyper.
Repolarizing. And then look what happens. Ooh, hyperpolarizing, and then back to rest. Okay. What I drew for you is called an action potential spike, the tracing of an action potential spike. Our goal is to understand what ion flux causes this shape. Right? Now here, we can just do this, right? Here was sodium. What? Influx, efflux, influx. Here must also be sodium influx. Now remember I told you that you could repolarize by, if we let sodium come in by diffusion, pump it back out. But remember I told you active transport takes longer than diffusion. This is fairly symmetrical. If what I told you, if we were just going to pump it back out, it would be something like this. Like that, right? It would take a long time to get it back out. And that won't work. And the reason that won't work is that won't let me fire another action potential. So I'm going to depolarize by diffusion, and then I'm going to repolarize by diffusion. But it's not diffusion of sodium. It's diffusion of what? Potassium. Potassium what? Influx or efflux? Efflux. Right. Sodium comes in, depolarized. Sodium channel closes, potassium channel opens, potassium goes out, repolarized. Very quick. And then we're down here, and then now back down in here, look what happens. If we hyperpolarize, I'm telling you, oops, more potassium leaked out than sodium came in, right? That means you're hyperpolarized, and at this point, sodium-potassium pumps need to do what? Say, okay, let's get the sodium back outside, let's get the potassium back inside, let's get us back to minus 70 where we started. Okay. So, sodium channels are open, threshold, voltage-gated sodium channels open, sodium influx. Voltage-gated sodium channels close, no more movement of sodium. Voltage-gated potassium channels fully open, potassium efflux. Back down here, potassium channels are closed. Sodium-potassium pumps work to restore. So here's what we need to understand. We need to understand that there are two ion channels that are really important. They're both voltage-gated. And it should make sense that they're voltage-gated, because what's going to cause them to open is a threshold stimulus. And the threshold stimulus is depolarizing to minus 55. So we have voltage-gated sodium channels, and we're going to have voltage-gated potassium channels. So that means gates open and close in response to voltage changes. So at minus 70, these guys are closed. Minus 70, closed. Okay? What value do they start to open at?
55.
This one opens right here. At minus 70 it's closed, but guess what? At minus 55 it opens. You okay with that? So it must open it opens. Fast or slow? The way to answer that is, do you start depolarizing really rapidly or not?
Fast.
Yeah, look how rapid that thing goes. It shoots up over there at minus 55. Shoots way open. So this is fast. Minus 55 here. This one also starts to open. But it must not open at the exact same time, because if it opened at the exact same time, then they cancel each other out, and we don't get this steep depolarization. So this potassium channel should open fast or slow? Slow. Because we have to have sodium influx before you get potassium efflux.